other points with this graph, and it's correct. Okay, talking about the minimum and maximum values, and I mentioned this just a second ago. Your graph either opens upward, which means your lead coefficient is a positive number. And when it opens upwards, that means that your y value is your minimum value. It doesn't get any lower than that. So that's your minimum value, is that y coordinate. If your graph opens downwards, it's because your lead coefficient is negative. And that means your graph is going to have a maximum value. So it opens down, it goes on and on and on forever down to negative infinity. But then it's going to cap out at that maximum y value of your vertex. So you're able to determine if it's going to have a minimum or a maximum value by A. So whatever A is determines if it's going to have a minimum or a maximum. Okay, so we have the quadratic f of x equals negative x squared plus 2x plus 3. We're determining whether it has a minimum or a maximum value. All we need to know to determine what it's going to have is A. So A is negative, which means your graph is going to open like this, which means it's going to cap out at that biggest y value. So it's going to have a maximum value. Okay. So that's literally all you need to know from that is what is A, and that'll tell you whether you're going to have a min or a max. Okay, so we have f of x equals negative x squared plus 2x plus 3. So we're going to state whether it has a minimum or a maximum, and we're actually going to go through the process of finding that minimum and maximum. So, first off, A is negative 1. Which means our graph's going to be opening this direction, which means we're going to end up with a max value. Okay, but we need to find that max value. So, which means we need to find our vertex. So to find our vertex, we have that x equals negative b over 2a. So b is 2, so negative 2 over 2 times a is negative 1. So I have negative 2 over negative 2, which is positive 1. So now I need to find the y of my vertex. So I have negative 1 squared plus 2 times 1 plus 3. So 1 squared is 1 times this negative in the front. So that's going to be a negative 1 plus 2 times 1 is 2 plus 3. There it goes. Okay, so we end up getting a positive 4. So our vertex is at 1, 4, which means we're going to have a max value at 4. Now, to talk about the domain and range, we don't even need the graph in front of us to talk about domain and range. The domain of all quadratics is negative infinity to positive infinity. Our range is determined by whether or not we have a minimum value or a maximum value. We have a maximum value, which means the highest y value is going to be 4, which means it's going on and on forever downward. So we're going to start going from negative infinity, and we're going to build and go all the way up until we hit 4, and that's where we'll stop. So our range is from negative infinity to 4. Okay, so we have f of x equals x squared plus 4x minus 1. We're determining whether it has a minimum or a maximum. So we're not even asked what it is yet. We're just asked what's it going to have. So a is a positive 1, which means your graph is opening this direction, which means we're starting at that lowest y value right there. So that means we're going to have a minimum value. You can't have both. It's not going to be none. So we're going to have a minimum value since it's opening upward. The y of our vertex is the lowest point. Okay, now we're going to find that value. So it's opening upward. We know it's going to be a min. So we need to find the vertex. So x equals negative b over 2a. So b is 4. So negative 4 over 2 times a is 1. So x equals negative 4 over 2, so negative 2. So then to find the y of my vertex, I'm plugging in negative 2. So negative 2 squared plus 4 times negative 2 minus 1. Negative 2 squared is 4, plus 4 times negative 2 is minus 8 minus 1. So 4 minus 8 is negative 4, minus 1 is negative 5. So our vertex is at negative 2, negative 5, which means our minimum y value is at negative 5. Okay, and now we're going to talk about the domain and range. So we already said that we have a minimum value at negative 5. So our domain is never going to change for a quadratic. So our domain is still negative infinity to positive infinity. And our range, since we have a minimum value, our lowest possible y value is we're starting at negative 5. So we're going to do a bracket, negative 5, and we're going on and on and on forever to infinity. Close that with a parenthesis. So there's our domain and range. And that's it for graphing our quadratics for now. Okay, so we used a table. We used equations to find our axis of symmetry, which is that x equals negative b over 2a. That same equation helps us find the x of our vertex. We find the y of our vertex by plugging in our x value of our axis of symmetry to solve for that y value of the vertex. Our y-intercept is always c. So this one would actually have a point at 0, negative 1, because that's our y-intercept. The domain of every single quadratic is negative infinity to positive infinity. And then our range is determined by whether or not we have a minimum or maximum value. And we find that minimum or maximum value from A. And that's it for graphing quadratics.